next thing's next. What'd you do after you learned points and stuff?
Slope.
The equations for stuff, right?
Mm-hmm.
Okay, so you guys know some equations for stuff already, right?
Yeah, like slope. Y equals mx plus b.
Yeah, we remember. Oh, we should talk about that.
Oh, goody. That's a great face.
So what if I wrote y was 2x plus 3?
Slope is 2, y-intercept is 3.
Y-intercept is 3.
And it's only on the xy plane.
Yeah, this is an xy thing, right?
Uh-huh.
Yeah.
You guys see that? So if I drew xy, I'd go, okay, I need to go up 3, and then
Up
over
2.
1, up 2.
Mm-hmm.
So I'm looking at a line, something like that.
Yeah, algebra.
What happens if you put a z-axis on that? Coming out at you. What did you do to control the z?
Z equals 0.
Is there a z control here? No. So this, right, that I would think of as a line in Calc 2, right? Other places, right? So in all your other math, this has been a line, right? Unfortunately today, this is a
Plane.
plane.
Mm-hmm.
Welcome to Calc 3. So if you want to get the line, what do you need?
So set z equals 0.
So this is a plane, right, in our three-dimensional field. Have you guys seen this symbol before?
Yeah.
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 Yeah, so I'd call this thing here, call this r squared. You guys see why?
Because all real numbers and 2
R
different
times
values.
an r, right?
Yeah.
So r cubed should be r 3 dimensions, right? If I wanted to talk about R3 with time, then I'd need...
But that wouldn't be an R3 unless it was equal to like
yeah, so this is a convention that we do with equations in Calc 3.
This isn't linear.
Parameterized.
No, stop doing that. So, in Calc 3...
We'll tell Meryl, she'll be very proud.
In Calc 3, especially with me, if something's not mentioned, right? So if you haven't specified the z, that means it's allowed to be whatever. Okay?
What's up, guys?
Just pull that. So especially that's true when I want to talk about like the xy plane. What's the equation for the xy plane?
Z equals 0.
Z equals
Yeah, that should just be given by z as 0, right? What does z as 0 say about x and y?
Nothing.
Nothing, right? So they can be anything. Just pull that. Okay. So we have to remember a little bit that our old equations are a little bit fussy here. Now, what if I wanted to make a function of 2 variables? Do you guys have any idea what that would look like? Oh, okay.
Yeah.
Good. Right, that shouldn't be a stretch. So, let's say, okay, f of x comma y,
Mm-hmm.
right?
X, comma y, comma z.
Oh, and we might, right? That would be a function of 3 variables. So we should remember how many dimensions are you going to need to graph something like this?
3.
3.
Yeah, number of variables plus 1 for the output, right?
Mm-hmm.
So if I say, okay, f of x and y is x times y, right? So think about what this does.
What do you mean by what it does?
It's like a bowl.
Well, like what's a physical interpretation of this? Maybe how does it look in space or something?
It's like a bowl, isn't it?
How about that?
Oh, it's
gonna be
wavy.
like a bowl.
It's
like,
wavy.
yeah? Okay.
Because you do have a negative output.
Area of square?
And a square.
Oh.
Squares only have one input, right?
Yeah.
Yeah.
Area of
Rectangle.
Parallelogram.
You guys see that?
Yeah.
So, if I think about, all right, here's an X, here's a Y, here's my output Z. Right, I want to plot some points that are on this. So a point that's going to be on the graph of this thing is going to look like what? Okay, let me ask you this. What's a point on the, oh, that's good. Yeah. Okay, how'd you know 0, 0, 0 was on there?
Well, it's the origins where they all meet.
Well, X is
It
0,
has to
Y is 0.
contain
You
the
set
0
those, and then
vector.
Z has to be 0.
R3
Yeah.
has to contain the 0
So
vector.
points on the graph of this,
I dropped it for a reason. Just shh.
so points on a graph of a three-dimensional function, right, are going to be an X, Y, and a Z that's given by
Function of X, Y.
f of X and Y. You guys remember that from Calc 1 someplace? Right? A point on a graph is a pair
X
that's
and
an
an F of
X,
X.
f of X, right? So this is the same thing, right? It's an input, comma, output. Your input in this case takes up 2 slots, but that's all it is, right? It's input, comma, output. Cool? So I know 0, 0, 0 is on there. What else do I know?
1, 1, 1.
Yeah.
1, 1, 1. Okay, so if I go over 1, back 1, I should go up 1.
Yeah. And then 2, 2, 4.
Okay, so those are going to kind of rise, right? What else do I know is on there?
-1, -1, -1.
-1, -1,
1,
1.
So you basically have like parabola on like the diagonal between Y and X.
Yeah? Why? Why is it a parabola on the diagonal?
It's like this
Y equals X.
square line.
Yeah, it's the line where it's a square, right? Mind blown. Yeah. Okay, so what else do I know about squares?
Always positive.
Yeah, I know the area is always positive. Okay, so I'm getting this parabola in here. I'm not going to draw it because that's going to mess the heck out of my picture. Okay, so I got a parabola along y equals x. And then I know that that the square is as big as it gets, right?
Yeah.
You guys remember that from optimization? So it's going to fall off the parabola on both sides, right?
Mm-hmm.
You guys see that? Maybe?
You got it graph.
I know. I'm going to have a really hard time graphing. How about, I have a good reason that it's going to be hard for me to draw this picture. Where else is it 0? Yeah, along any of the axes. You guys see that? So it goes through these axes. Just dodge that one, because that's going to be behind what I'm drawing here. And then 0 along this axis. It's also 0 along that axis. See this?
Then you have this square but negative along the y equals negative x.
Yeah, if there's another parabola pointed down along y is negative x. You see that? So there's like a parabola in this direction, downward parabola in that direction, and then it's 0 along these guys. It's getting messy fast.
That's only for a square, or is that for a rectangle?
So this is only for rectangles.
Bless you.
The squares really only exist along that diagonal because that's where y equals x, right?
Yeah.
You guys see that I'm having a hard time drawing this, and that's gonna be the case. So if I want to draw this, what do I go to? Like if I want a good picture,
Computer.
yeah, 3D modeling program is totally overkill. Yeah, Wolfram. Go to Wolfram, type this in, you'll get a nice picture. It'll look a little bit like a handkerchief draped over a positive parabola and a negative parabola. There's nothing interesting going on in between, it's just kind of dropping towards the other one.
What's
So-
the website we can use for that?
Wolfram Alpha. Wolfram Alpha. So, to get a better tool to graph things, we noticed that cross section, right? That parabola is really helping my understanding here, even if it's not helping me draw this. Maybe let me take a quick whack at drawing this, and we'll see if it's gonna go okay. Okay, so I need a parabola like this, right? So I'm drawing this crooked now. Okay, see that? And then I need a parabola coming down this way. And a parabola going back off the other side. And then, now I'd really like to know about a cross section or something. You guys see that? How could I cross section this thing? Like, how could you slice this jazz up to make sense out of it?
Take washers.
Yeah, we could slice horizontally to make sense of it. You see that? So how would I make a horizontal slice in this thing? How do you figure out what a horizontal slice looks like?
Oh, it's a plane.
Yeah, I want to specify a plane, right? But I want to specify specifically a plane that's, yeah, that's a Z, right? So if I want to look at like 2 or something, right? I want to know when this function's 2. How do I look at that? Yeah, I set x equals, or the formula f of x, right? X times y equal to the z I'm considering, right? And then do you guys know what x times y is 2 looks like? Probably not. How about this?
Y equals 2 over x.
Y changed my handwriting on y. But I know what y is 2 over x looks like, right? Yeah. That's a hyperbola inflated, right? Yeah?
I'm sure of that.
Okay, so let me draw a different picture. I'm going to draw an XY plane picture, right? And I'm going to draw, okay, let's see. So 0, when this thing is 0, right, it's the axes. You guys with that?
Mm-hmm.
So I'm going to color these guys. And I'm going to write
Z equals 0.
Z equals 0 for the black stuff, right? Then I'm going to take out another color, and I'm going to say set this equal to 1 or something. So what's 1 look like?
1 and 1. Or it's a
So
circle
I'm
in
looking
there.
for when x, y is 1. That looks like y is 1 over x. 1 over x looks like this, right? You see that? Is there another marker in that bag there?
This one's mine.
Cool. So now the purple, maybe we'll do this bit. Right? That looks like this thing blown up, right? So blown up's gonna, what's blown up look? How do you double a function? What does that do in terms of shifting?
Makes all the y values like that.
Yeah, it just makes the y values twice as big, so that's going to look a little bit like vertical shift. It's not quite, but. Okay. Cool. Okay, so are you envisioning a topographic map? You guys see that? Here's your parabola where it rises. And a level curve on this thing looks like one of these guys, right?
Mm-hmm.
Yeah, this is actually why I wanted to teach Calc 3 down here. You guys see why that's a good idea? So, in general, an f of xy is some formula. Looks like kind of a handkerchief draped over stuff, right? And our tool for exploring what those things look like is these level curves. Right? We set z equal to something, we get a one-dimensional function, right? A function we know and love, right? We solve for it, we graph it, that's a level curve. You guys see that? So I'm setting a height, right? When you look at a topographic map, you guys all know what a topographic map is. Please tell me. I'll go outside enough to know what this is. So when you look at a topographic map, it's drawing level curves, right? When you look at the weather, they draw isoclines. You guys know what I mean? You've seen a weatherman enough to have seen one of these, like, I don't know what the hell the United States looks like. Something like this. Really loosely. And there's these little lines,
Kinda like
right, that go like this.
Texas would be angry with you at the moment.
Yeah, you left out Texas, so.
They'll get over it.
They
I
never
don't even
do.
want to be here.
I mean,
so.
except for Florida, Texas,
So
and
what are
Maine
these?
were basically
What
square.
are these lines talking about in terms of temperature?
Temperature zones.
Sometimes they do pressure zones, yeah.
But their
So
temperatures
when they're
are
drawing
the
pressure
same.
zones, those lines represent equal pressure. When they're doing temperature, what do they represent?
Same temp.
Yeah, equal temperature along the line. So if you were to watch them, they might read something like 75, 80, 85, 90. Okay? It's kind of with me on that? So mine here, right? My blue should read Z is 1, and my purple should read Z is 2. Could I get more of these?
You'll get an infinite amount.
Yeah, I could certainly get an infinite number of them. It might be really easy to pick nice ones. Cool. So how about the other ones? Is there anything in here?
Negative.
Negative.
Oh yeah, those are the level curves for negatives, right? You guys see that? So if I did like z is -1, what would that look like? So that'd be y is -1 over x, right? Which is this blue one, but what?
But flipped across the y-axis.
But flipped over the
Oh, the x-axis, yeah.
x-axis, right? Because it's a vertical flip. And so I'll get something like this. But now these are representing negative values, right? So in my picture here, they'd look like this. And this is where my picture degenerated, right? You guys will see that? Because now they're coming out at me, and now I have no idea what the hell's going on. Cool? And then there's that one, this black one. If I put that on here,
It really falls apart.
that's this x, right? You guys see that? That x is weird, right? You guys want to go see what that x looks like physically? Alright, turn that thing off. Let's go for an adventure.